recorder up and running. All right, so the homework assignment was due about 1 minute ago. So now it's time to talk about it so that you guys know what it is supposed to be, or what the solution is supposed to look like. So let's start with that one, and then we'll go ahead and finish up subroutines today. Yep. You do not see a homework assignment. Well, let's see. Go to activities, go to assignments, and we have sub one. That's the homework assignment.
It didn't show up on the calendar like other ones did?
Yeah. It did not?
Just if you go down, scroll down on the screen, scroll to the bottom, and on the blue pane will have assignments. Right, should.
Okay, let's check the calendar.
And your time was till 10:30 a.m.
Yeah, I changed that. Yeah, thank you. Somebody sent me an email and go like, that's not the usual time. Yep. So go to the calendar. Yep, it's there.
It wasn't there before.
Wasn't there yesterday.
Wasn't there yesterday?
It wasn't there all week. I didn't see it since
It was
here.
Yep.
It actually showed up in the morning. I got on and I was like, do you have the homework? And it showed up, but it never showed up before because I checked the day.
That is odd.
Extension.
I don't know about that because because there are 35 submissions
Out of 40.
out of 42. So
That was your fault.
Yeah.
That is still hanging on.
No, it's not my fault. Good try. Good try, but it's not my fault. See, I learned how to say no. No, it is not my fault. All right. So it is not my fault because there are 35 people who turn it in.
I just 35 people figured it out, but it is your fault for misplacing the time.
Misplacing the time to 10:30 a.m. this morning. So I changed it back to 7 p.m. That's the change that I make. So unless you think that you have to turn it in at 10:30 and you spend too much time in the morning to do it, that will be my fault. But not being able to turn it in at 7 p.m. is not my fault. Because we talked about in class.
How about not being able to find it?
Oh, it can. What? I don't know how these 35 people found it. Yep.
Yeah, go to topic 7.
Sorry?
I have to go through the topics to actually find it.
You should be able to find it in the topic itself, and also from the assignment part. So I don't know. I mean, 35 out of 42. I would rate it, basically the way it is. I mean, I really cannot think of any reason why, 35 people can find it and then 7 people cannot. All right. Well, let's take a look at it, and we'll get through with this stuff, and then move on to maybe another topic today. So let's see if we can finish subroutines today. Let's go ahead and somebody actually asked me a question in the previous class, about this particular homework assignment, and so All right. To start with this one, there are no local variables. There was one confusion. The one person who asked me the question did it assuming that n was a local variable. So if n is a local variable, then it behaves entirely differently. In fact, in some cases it doesn't even make sense. But I think that person kind of mixed up the concept of a local variable with a global one. So in this case, let's trace the subroutine. We have comments as a column because we do have one condition to evaluate on line 2, and then we have line number. And in this case, how many global variables do we have? 2. We have exactly 2 because x and n are referred to outside of the definition of a subroutine. So that means they have to be global variables. There's no way x or n can be local variables in this case. So that means I need to allocate 2 columns for the global variables x and n over here. The order is not important. If you want to allocate n first and then for x, hey, no problem, it's the same. The precondition is unknown for both because initially, unless I tell you something about the initial value of a global variable, they usually do not start with any specific value. And then we move on to the first line that is outside of the definition of a subroutine. In this case, is line 8. Line 8 is initializing x to 2. Line 9 is initializing n to 3. And then we move on to line 10. Line 10 is invoking a subroutine. In this case, we have to remember the return line number, which is line 11. And there are no local variables. So column E is all that we need to allocate when we invoke the subroutine. Are there any questions at this point? Okay. Inside the subroutine, we start with line 2. We compare n to 0. N is greater than 0 is true. So we move on to line 3. We subtract 1 from n. N goes from 3 to 2. Then we move on to line 4. Line 4 is invoking the subroutine again. So we have to allocate another column, leftmost available column, for the return line number. In this case, the return line number is 5. And then we move on to the subroutine itself, starting on line 2 again. N is greater than 0 is still true because it now has a value of 2. 2 is greater than 0 is true. So we move on to line 3 again. And you can see this part is pretty much the same. So we just copy and paste it here. And then we move on to line 2 again.
Subtract.
Oh, we subtract one first. That's right. So move that down 1 by 1 line. We subtract 1 from n, so n goes from 2 to 1. And then on line 4, we do the subroutine call. Move it back to here. And then we go back to line 2. N is greater than 0 is true. We go to line 3. We subtract 1 from n. N goes from 1 to 0. And we have one last call to sub1 before we return. Because even though at this point we understand that the next invocation is not going to do anything, we still have to invoke it because we are already on line 4. So on line 4, we have to invoke it and allocate the column for return line number and indicate we have to return to line 5. And now we can move on to the subroutine on line 2. And then where did we go this time? Well, first of all, let's evaluate the condition, right? N is greater than 0 is false. And then where do we go?
7.
We go to line 7 because we don't even have an else branch in this case. When the condition is false, there's nothing to do in the conditional statement. So we move on to line 7. Line 7 is the end of a subroutine. And what we do is we go to the rightmost active return line number. In this case, it's column H. It tells us that to continue execution on line 5. And then we have no use of this column anymore. And so we strike it out. Now we are on line 5. Line 5 says, x gets x plus 1. Let's go ahead and do it. X had a value of 2. Now it has a value of 3. After line 5, where do we go?
7.
We go to line 7, which is the end of a subroutine. Column H is now gone, so the rightmost return line number is column G. Column G tells us to continue execution on line 5, and that's where we go. And then we have no use of column G anymore. Indicate that is the case, and now we're back onto line 5. On line 5, we add 1 to x. X goes from 3 to 4, and then we go to line 7 again. And on line 7, we look up the rightmost active return line number. In this case, it is column F. It tells us to continue execution on line 5. Make a note of that, and then we have no use of that column anymore. We can indicate so. And now we are on line 5 again. We add 1 to x. X goes from 4 to 5. And then we go to line 7. and then we look up the rightmost return line number. In this case, it's column E. It tells us to continue execution on line 11. And then we have no use of that column anymore. And now we continue execution on line 11. Any questions about the trace up to this point? The next step is what some people probably might make one mistake, is when we invoke the subroutine again on line 11, where do we allocate the return line number?
Column E.
Column E is the leftmost available column, okay, because it is already deallocated before, and now it is available again. So this is the column that we reallocate for the return line number for line 11 when we invoke sub1 again. So you might think, oh no, we're going to have to go through all this trouble again and then come back. No. We go to line 2, and it's already
Need a
0.
candidate return line.
Oh,
As
right,
a
right.
note.
Toast.
Yeah.
Post. Okay, that's our return line number. We go to line 2, and then we evaluate the condition. It is now false, right? Because 0 is greater than 0 is false. We never reset n back to its original value. So it is still 0 at this point. So that's why the condition is false. We skip over the entire conditional statement and end up on line 7. On line 7, it is the end of a subroutine. We look up the return line number, the rightmost active return line number, which is column E in this case. It tells us to continue execution at post. And then we have no use of that column anymore. And now we continue execution at post, which means we are now at the finish line and we are all done. Hmm?
Oh, no problem.
No problem, you get it?
Yeah.
Okay. So that's basically this trace here. The problem with this one is the homework assignment is lagging a little bit behind the topic in class. So some people, try to use local variables or parameters, mixing up with this particular homework assignment. But fortunately, that person asked me in the previous class, so that was cleared away, without any problem. So are there any questions about this homework assignment? Okay. We'll do one more exercise regarding returning values. And this one has to do with the calculation or the use of Fibonacci numbers. Because it's kind of interesting in a way now that we know how to do return values. It is going to be one of the more confusing ones. So let's go ahead and take a look at Fibonacci numbers first. And then we'll take a look at the implementation and see how it is going to be kind of interesting. This is the recursive definition of Fibonacci. F of n is f of n minus 1, the whole thing, plus f of n minus 2. That's the recursive definition. So if you use the recursive definition, eventually you will get to f of 0 or f of 1, which by definition is f of 0 equals to 0, f of 1 equals to 1. But for all of the other positive integers, we can use the recursive definition to compute the Fibonacci number for those particular ones. So when we write a subroutine to do this, okay, so we'll say define sub, in this case, Fibonacci number, okay, fib, and it requires only one parameter, which is n, kind of like factorial. It only has one input, which is the number. We want to find the Fibonacci number of n in this case. The next one is how do we write the pseudocode for this particular subroutine based on its definition? And also based on what we already know with factorial. With factorial, when do we stop the recursion? When n equals to 0, because 0 factorial by definition is 1. In this case, when can we stop? When n equals to 1. Well, there are two cases now, okay? When n equals to 0, we can stop. Because we can say, oh, the Fibonacci number of 0 is 0 itself.
Is it 0 or 1?
No.
No, if n
Well, I suppose you could do that, because if n equals to 0, then the Fibonacci number is 0 itself. When n equals to 1, the Fibonacci of 1 is 1. So you can just return n when n equals to 0 or 1. But I'm going to use this method here just so that it is a little bit more clear to differentiate the two cases. I mean, it's not really that much more code in this case. For all of the other numbers, I'm going to return invoke Fibonacci, and in this case, I use n minus 1 to specify the end of the next invocation, plus invoke again Fibonacci n minus 2 to specify the next one. Yep.
Could you also do it by saying if n equals 0 or n equals 1, then return n?
Yep. I think that's what I just said.
No, but I'm saying on here, because you got it going, else if.
You mean on line 8?
Well, just this whole from 3 to 8.
Yes. No, from line 3 to line 6, you can replace that with if n equals to 0 or n equals to 1, then return n. That will work. So you can combine line 3, 4, 5, and 6 into one single case in the conditional statement. But I want to separate these because the definition of Fibonacci number clearly states that f of 0 is 0, f of 1 is 1. So I'm going to use that definition so that it's not, it's the same as the recursive definition.
Just for practicality, what would you use this for in the actual program? What would you use this for in a real program?
You mean
Fibonacci.
why Fibonacci numbers are useful?
Yeah.
Well, if you watch, what's the name of that movie?
Da Vinci Code?
Yeah, the Da Vinci Code, you can use it for passwords. No, that's just, but if you look up, this particular wiki page, you will find out why it is useful. But as far as we are concerned, we just want to write the code to, we want to write the pseudocode to do the calculation, but only for the purpose of illustrating, how do we trace subroutines that return values. In this case, it is confusing because we have two invocations on the very same line that contains the return statement. So that's why it is it can be confusing when the concept is not understood, or when people do not just apply mechanically and say, oh, the return statement is just going to do this. Okay, so that's why I chose this particular example. So define submain, and we'll just say print invoke fib, and let's see. We'll invoke maybe 2. Okay, 2 would be a good one. Because if I use a number that is too high, it's going to be a very long trace. 2 would be good. 2, no, maybe 3. Change my mind. Okay, and define sub, invoke main. Now we have to fix all the indentations. All right, so now we write down the line numbers and ready to perform the trace. The only problem is line 8 is kind of long, so I'll try to find a way to kind of make it easier to understand. Maybe I can just make this line wrap around, so that way it doesn't take up as much space horizontally. So go to alignment, wrap text, and so this way, I need to change the width of the column. There we go. Now we can trace it. We definitely need comments because we do have 2 conditions to evaluate in this pseudocode. We got line number. There are no global variables in this case. We have 1 parameter in one single subroutine, and that's all that we have. We don't have any passed by reference parameters. We don't have any local variables. We just have 1 single by value parameter. And it is simplified only because we are using return values. if we do not use the concept of return values, this would have been a lot more messier because we need to use passing by reference in order to pass the result back so they can be utilized later. Okay, so let's go ahead and start with line 14. It is invoking main, and all we need is a return line number here. Why do you think we just need a return line number and not a return info in this case? What is the reason? When do we use a return line number, and when do we use the concept of a return info? When it returns a value, then we use return info because we need to go back to the same line to finish up some unfinished business. All right. In this case, main does not return a value. It has a print statement, but it's not a return statement, and that's why we don't need a return info in this case. If you want to use a return info, that's actually okay too. If you want to use return info, it is just also just post, because it is telling me where to continue execution, and we are continuing execution at post in this case. So return info is more general, but since we already have talked about the concept of a return line number, I'm just going to keep using that concept. Now that we have set up the return line number, we can continue execution in main. And inside main, do I need any local variables, or do I need to allocate anything other than just the return line number? Nope, not the subroutine itself. Okay, so main does not have any local variables. It does not have any by value parameter. It doesn't have any by reference parameters. So I don't have to set up any additional columns just yet. Okay, until I get to line 12. When I get to line 12, eventually the last operation on line 12 is to print a number to the screen or printer. But can I do that now? No, not yet. What do I need to do first? I have to get the invocation done first, because that's going to give me the value that I'm supposed to print. So in this case, I have to do the invocation of fib, or Fibonacci. And do I use return line number, or do I use the other one? Return info. We have to use return info because the subroutine that we're invoking is returning a value. That is the reason why we have to use return info in this case. What do you think the return info should look like? In other words, what do I have to write here to remind myself what to do after the subroutine is done with this invocation? We have to indicate the line number first. Okay, so you have to write down the line number first, which is line 12, colon, and then the print operation still needs to be done, so that's why we need to write that down too. And then we use parentheses and a question mark to replace the invocation, because the entire invocation of Fibonacci is going to give me a single value so that I can print that one single value. But since I'm invoking Fibonacci, and Fibonacci does have one by value parameter n, I also have to allocate for that parameter and give it a value. What do I put here? 3, because it's coming from this 3 here to specify parameter n. And now we can continue execution in the Fibonacci subroutine, starting on line 3. N equal to 0 is, this is n, okay, n equals to 3 is false. We continue to which line? Line 5. N equals to 1 is also false. And so now we end up on line 8. Line 8, not line 7, because we don't trace the else line. Okay, what do we do on line 7? That looks like a big, huge mess to me. Well, you have to figure out what we can do at this point. We cannot do the return because the value that we are supposed to return depends on the addition. We cannot do the addition because the left-hand side and the right-hand side of the addition has to invoke a subroutine. Now, with the 2 subroutine invocations, you can pick one. Okay, you can pick the left-hand side or the right-hand side. The traditional way is just to pick the left-hand side because that's how we read pseudocode. So that's what we can pick here. So we have to evaluate n minus 1 first because we have to use that expression to specify parameter n for the next invocation of Fibonacci. n currently has a value of 3. So when you evaluate n minus 1 here, n minus 1 will give you 2. So that means we have to invoke Fibonacci again, but this time using 2 to specify the by value parameter n. All right, so let's take care of the easy part first. The easy part is, we are invoking Fibonacci again, and the parameter n now has a value of 2. That's the easy part. The difficult part is how do we specify the return info. We know it's a return info because Fibonacci is returning a value. And in this case, I will split the screen this way, just so that we have all the room that we need in order to specify the return info. When we specify the return info, we are going to copy the entire line 8 except for the invocation that we are dealing with at this point. We can only deal with one invocation at a time. So that means we have to say, okay, we are on line 8, we have to go back to line 8 to finish up the next operation. But on line 8, the return operation definitely is not done yet. But the first invocation of Fibonacci is the one that we are taking care of at this point, and that's the one that we replace with a single question mark. What about the addition? Well, we have to do it after we return, so we have to keep it here. And the second invocation is also going to be done later on, so I'm just going to copy that exactly the way it is, and that becomes the return info for the second invocation of Fibonacci. Are there any questions about how the return info column is set up this time? No questions? Okay. The most important part really is to understand why do we have to represent it like this? Because return info is telling us what do we have to do when Fibonacci is done. When we come back, when it's all done, where do we continue execution? And what else do we have to do on line 8? That's what it's doing. Once we set this up, we can now continue execution in the subroutine again. Where do we start? We start on line 3. Yep. And on line 3, we perform the comparison. N equals to 0 is false. N equals to 1 is false. So that's on line 5. Now we are on to line 8 again. So we have another recursion in this case. So at this point, I think it's okay to copy and paste this, except we have to change n because n is now 1. Are we still doing okay so far with this trace? Okay, yep.
We have the rule sheet.
Yes, we do. All right, so now we continue execution in the subroutine from the beginning, which is on line 3. N equals to 0 is false. We move on to line 5. N equals to 1 is, come on, true. Okay. So when the condition of line 5 is true, we move on to line 6. Line 6 is a return statement. It is just returning a value of 1. What do we do when we execute a return statement? Copy and paste and then change the question mark, right? Okay, so you have to remember when we execute a return statement, we copy and paste the return info cell, change the question mark to the value that we are returning, and that's all that you have to do with a return statement when you execute a return statement. So in this case, the rightmost return info cell is this one here. And that's the one that we are going to copy and paste, change the question mark to the value that we are returning. Remind me again, what value are we returning in this case?
1.
Returning a 1, so that question mark gets replaced by a single 1. And then where do we go next after line 6? We go to line 10 because line 6 is the end of one of the branches. So we get out of the entire multi-branch conditional statement. We now get to line 10. What do we do on line 10? Line 10 is the end of a subroutine. So how do we know where to continue execution? Exactly, we make use of the return info cell. So this is the return info cell, and in this class, unlike the notes, I'm copying and pasting this entire thing over onto the line number column, which makes it really wide. But that's okay, because we can still just refer to this line here. And then we have no use of these two columns anymore, because at the end of a subroutine, we have to remember to deallocate all the columns that we allocated for that particular invocation. So that's why we have to strike through the entire thing, both the return info column as well as the column for n. And now we are back onto line 8. And let me switch the column first, and then we'll go ahead and expose this line that we are supposed to execute at this point. Running out of space here. There we go. Okay, this is what line 8 looks like at this point. We have one of the invocations resolved to a single value, but in order to complete the entire operation on this line 8, what else do we have to do? Invoke again, because this time we want to take care of the right-hand side. So that means we have to invoke again, but this time, what are we going to use as the parameter for this new invocation of Fibonacci? Let me show you the current context again. So the current context is columns F and column G. So that n is referring to column G, which is 2. 2 minus 2 is 0. So that's what we need to use, is a 0 to specify parameter n for the new invocation. At this point, we have to reallocate column H and column I, because those are my leftmost available columns. So I'm going to reuse column H for my return info and reuse column I for parameter n. The return info this time is going to be different because we already have the first one resolved. The first question mark is already resolved to 1, and now we're trying to resolve the second one. So that's why the second one is the one that is now replaced with a single question mark, but we kept the one that we have already resolved. N, on the other hand, is going to be 0 because n, the current n is 2. 2 minus 2 is 0, and that's why we are using a 0 to specify the new parameter n. Are we still doing okay so far? Because I cannot show you all the previous columns because it's just, my screen is not big enough or wide enough for that. Are we still doing okay? Okay. So once I set up all the columns, I continue execution in the subroutine again, starting on line 3. And this time it's pretty easy because n equals to 0 is true. So we go to line 4. Line 4 is returning the value of 0. So what do we do again when we return a value?
Copy and paste.
Copy and paste, change the question mark, right? So in this case, we copy and paste the current rightmost return info cell, paste it, change the question mark to the value that we're returning. In this case, it is 0. And we are done executing the return statement. Okay, I just moved it around a little bit. Oh, that's right. There we go. That's where we were. Okay. It is confusing, isn't it? Because the line that we are executing is line 6. We are executing a return statement. Did I do something wrong here?
That's a different one.
It's a different one. No wonder it doesn't look right. Okay, gotta hide all the ones. There we go. Okay, so we are on line 4. We are returning a 0. We copy and paste the return info cell. We change the question mark to the value that we are returning, but do not evaluate the addition at this point. This is not the time to evaluate and say, oh, I know what is the result of 1 plus 0, because we are not on line 8 yet. So we do not simplify and evaluate, oh, 1 plus 0 is just 1. This is not the time to do it. So after line 4, we go to line 10. And line 10 is the end of the entire subroutine. So as we did before, we deallocate both of these columns, but we can only do that after we make a note of, oh, we are supposed to go back onto line 8, and now line 8 looks like this. Because we have just resolved both invocations. The first one, or the left one, resolved to a value of 1. The one to the right evaluates to a value of 0. So now the line 8 becomes just 1 plus 0. But now is not the time to do it just yet, because we are still on line 10 at this point. So we have to remember to deallocate both of the columns. Column H and column I need to be deallocated first. And then we can now go back to line 8. And line 8 at this point looks like this. Can we actually perform the addition and then the return operation? Yeah. Yep. We don't have any further invocations to do. So now is the time to say, oh, okay, 1 plus 0 is 1, and we need to return that value of 1. Okay, so we are returning a single value of 1. When we execute a return statement, in this case it's equivalent to returning 1, what do we do? Well, we cannot use column H anymore because it is deallocated. So we have to go back and say, okay, which one do we have to use? Column F is the rightmost return info cell at this point. So what we do is we copy this one and we paste it over here, and we change the question mark to 1 because we are returning a value of 1, and we are done with line 8, done with executing line 8 at this point. Any questions about this? It looks a little bit convoluted, doesn't it? But the mechanism has not changed. Okay, from maybe about 2 classes or 1 class ago, when we first talked about how to return a value from a subroutine, that mechanism has not changed. This just kind of makes it look confusing, but if you just follow the mechanism itself, it is still doing pretty much the same thing, as before. We just have to kind of track this carefully to find out exactly what it is doing. Okay, so now we are done with this line 8. After line 8, we end the conditional statement. We continue execution on line 10. What do we do on line 10? Line 10 is going to locate the rightmost return info or return line number. In this case, the rightmost return info is column F, and column F looks like this. So we'll make a note of this and say this is what we need to do after we perform the return, after we end the subroutine invocation. So we make a note of that, and then we say, oh, okay, we don't need these 2 columns anymore, and we'll go ahead and deallocate both of those columns. In other words, we're still doing pretty much the same thing from the very beginning of the discussion of subroutines. It's just that, it looks confusing, but it's, if you follow the mechanism, it's not that confusing. Now we're back onto line 8. And this is what we need to do on line 8. Can I do the addition now? No. Why can't I do the addition? We have an invocation here, okay? So I have to perform the invocation again in this case. So we have to first look up, okay, but which n are we talking about? Oh, let's take a look. Yeah. We have to kind of flip through it a little bit to find out. Okay, column F is now deallocated, and okay, looks like I have to split the top again. Oops. There we go. N is now 3. I don't know why that one is wider. Let me just double check. Column F is deallocated, so that means your column D and column E is now by context. And because that is now by context, when I invoke, when I have to invoke Fibonacci again, this time using n minus 2, this n has a value of 3, so I'm invoking Fibonacci again with a value of 1 passing to the parameter n in this case. The leftmost available column is definitely not column D or column E. Those are still in use. The leftmost available column is column F. So we have to reuse column F here and say, okay, I'm reallocating this one for return info, and I'm reallocating column G for parameter n. We know what parameter n is already. It is just 1. And now we have to specify the return info cell, which is go back to line 8 after the subroutine is done. The left-hand side is already resolved. Okay, it is resolved to a single 1. The other one on the right-hand side is the one that we are trying to resolve now, and that's why it is the one that is being replaced with a question mark. And after we set up column F and column G, we can continue execution in the subroutine starting on line 3. On line 3, we compare n to 0, n is 1, n equals to 0 is false. We move on to line 5, we compare n to 1, n equals to 1 is true. We now move on to line 6. Line 6 is going to return a value of 1, which means we're going to copy and paste the return info cell, change the question mark to 1, because that's what a return statement does when we execute it. And once again, do not do the simplification here. We are not going to say, oh, 1 plus 1 is 2. Well, we all know that, but this is not the right time to do the evaluation of 1 plus 1 equals 2. So we just leave it the way it is, because our job when we execute a return statement is simply to change the question mark to a single value. After line 6, we move on to line 10. Line 10 is the end of the subroutine. We make a note of what we have to do after this, which is continuing onto line 8. And now line 8 looks like this. So we copy and paste that into the line number column. And then we have no use of these two columns anymore. We just copy and paste it and change the format to strike out so that we know they are now deallocated. And the rest, I think I can, well, I still have to do this scroll here. Now the context is back to column D and column E. The statement itself is return 1 plus 1. Now is the time to evaluate 1 plus 1 and say, oh, 1 plus 1 is just 2, and I know how to return 2. Return a single value of 2. When you return a single value of 2, you look up the rightmost return info cell. In this case, it's column D, because everything else is now deallocated. So you just copy and paste it. Change the question mark to the value that we're returning. Once again, what value are we returning? 2. We're returning a value of 2. So now we just change it to a 2, but this is not the right time to do the printing because we are not on line 12. We're actually on line 8 right now, returning a single value of 2. And after line 8, we go to the end of the subroutine on line 10. We take note of where do we go next to continue execution. We are going to line 12 to print a value of 2. Once we make use of that information, we don't have use of these two columns anymore. We deallocate those columns. And now we are on line 12. And at this point, I don't need this to split the screen anymore because all the other columns are deallocated except for column C. So on line 12, it is just printing a value of 2. Well, sure, we can do that. We just go ahead and print the value of 2 either to the screen, the printer, or something else. And then we move on to line 13. Line 13 is the end of the main subroutine. I look up the return line number on column C, and then it tells me to continue execution at post. Make a note of that, and then we can deallocate that particular column. And now we continue execution at post, and we are all done. What do you think the shape looks like? Because we are only looking at the entire spreadsheet at a very local level. If I zoom out, what do you think it looks like? It's not the usual shape. The usual shape, like factorial, just goes all the way out to the right-hand side and then it retracts, right? This one is not exactly like that. Why do you think it's a little bit different? It goes all the way out, and then it retracts a little bit, and then it extends out again. So let's go ahead and take a look, after we zoom out the entire spreadsheet and remove all the split screen stuff. Just change the zoom. This is the general shape of this particular trace. You can see how it goes all the way out, do the calculations, and let's see. It retracts here first, it extends out again, it retracts, extends out again, retract, like that. Okay. Are there any questions about this trace? Okay, what mechanisms did we use when we traced this particular algorithm? We have the regular subroutine call, invocation, the return line number. We have invoking a subroutine that has a return value, so that means we had to use return info, and then we have the return statement itself, and that's about it. And also passing by the value. Those are the only concepts that we have exercised in this particular trace. Are there any questions about this trace? It's a little bit hard to look at the entire thing because when I cannot display this the trace like this and still have everybody to be able to read the text, especially people in the back. So that's why this is a little bit hard to visualize, because I can only show you a portion of the trace at each at any particular time. And if I want to expand line number, that makes it even wider and even harder to look at, when we are at a local level. Any questions about this one?
Maybe we could do another one.
Do another one like this?
Well,
We just get this one uploaded in Moodle so we can look at it later.
Yeah, I think this one I'm going to save and upload just because it is a little bit more complicated
I was
and
trying to
it's
follow
difficult to
without seeing everything.
to write it down at the same time. Yep, I'm going to upload this one.
not like I don't have questions, I just don't know what to ask.
Exactly.
Well, that's okay. Keep thinking about it. Okay, because the thought process of trying to figure out how to ask a question, oftentimes will answer your own question. So I'm going to save it and upload it first while you think about your question. First. So how's that question coming along? You think I might be able to upload the file before? Well, keep thinking. I mean, that's how we process that information. Add file. Example. So the file is uploaded. How's that question coming along? It's down here. Okay, let me kind of go back to an example that we have already gone through, but earlier in the class. And okay, maybe I'll do one that has no recursion. Okay, one that has no recursion and no parameter, and see if we can track that one down first. Because if you can track that one down, this one is about the same. It's just a little bit more complicated. Okay, so we'll go ahead and start with another example. And and this time we'll start with 1. Okay. So this is what it is. Okay, we'll define sub, and Johnny is going to return 5. From the lack of response, I can kind of gauge the age group of this class.
It was a fantastic movie.
Yes. But if you look up the database online, it only got like 3 stars out of 5.
Oh yeah.
Yeah.
Wonderful movie. Wonderful.
And then we'll define another subroutine. Let's see.
Pikachu.
Hmm?
Pikachu.
No, I need something that has numbers.
That line, Johnny 5 is alive.
Yes.
It's stuck in my head.
Mr. X? I don't know.
Okay, I know which one. We'll just call it DS, and then return deep space 9, right? Well, I have another substitution for deep space, but it's not appropriate for the class. If you follow the storyline, you probably know what it is. Okay, so we have 2 subroutines, and then we would need another one. Define sub. This one is just add. Okay. Maybe not. I think it's okay to have main here. So I'm just going to define sub main here, and we'll say print invoke Johnny plus invoke DS and define sub. Are you seeing some resemblance between this program and the one before?
Yes.
Okay. So if we can find out how to get this one done, the other one is about the same. It really is not that much more complicated than this one, except the other one has got parameters and some recursion going on. But the mechanism of returning a value and using that value in an expression is pretty much the same. Okay. So we'll go ahead and find out what this one is going to do. And the new trace. Now before I go on actually to trace the algorithm, can someone guess how many columns it's going to use up? Altogether, okay, including the return line number for main itself. So I'm just kind of testing you whether you can kind of track this one in your mind and figure out, okay, we need 1 column for this, we need 1 column for that, we need 1 column for that, but can we reuse a column? Okay, that's really the question. So in other words, how many columns am I going to allocate in the spreadsheet, considering that some columns may be reusable?
2.
2, that's right. Yep, because Johnny and DS can share the same column. Because by the time we invoke DS, Johnny is done already, so we can actually reuse that column. Right? That's good. So we'll go ahead and start with this trace. We can start with line number because there are no conditions to evaluate in this case. The precondition has got nothing to say because we do not have any variables, local or global in this case. Starting on line 10, we need 1 right away for the main subroutine. We are returning to post. And then we continue execution in the main subroutine starting on line 8. Line 8 is a print statement. I cannot do the print just yet because I can't even do the addition. That's because both sides of the addition are invocations of subroutines. But I can only invoke 1 subroutine at a time. So that is also important, is to remember when you invoke subroutines, you can only do 1 at a time. You cannot invoke both subroutines at the same time. So that means now we need to use return info because when we invoke Johnny, we have to come back on the same line, which is line 8, and say, okay, what else do we have to do on line 8? That's what column C is going to remember. We have to go back onto line 8. The print part is not done yet. We will have a value instead of invoke Johnny. The addition is not done yet because the right-hand side invoke DS would still be the same as that one. It needs to be resolved at that point. So once we set up column C, we can continue execution in Johnny starting on line 2. The subroutine Johnny doesn't do a whole lot. All it does is to return 5 immediately. So that means we look up column C, the rightmost return info cell, copy and paste it, change the question mark to the value that we are returning, which is 5 in this case, and then we move on to line 3, the end of the subroutine Johnny. We copy and paste return info cell. Well, actually, I take it back. We have to make a note of where to go next. So copy and paste the return info cell entirely. Then we can mark return info as deallocated. Like that. Now we continue execution on line 8. But line 8 doesn't look like the line 8 in the pseudocode itself anymore because we just resolved what invoke Johnny, what is the value of invoke Johnny. Now we can move on to the other one, invoke DS, and we're going to reallocate column C for our return info cell because column C is at this point the leftmost available column. So now we reallocate that column, and we have to write down. I'm just trying to make sure that we can display both columns at the same time. There we go. So with this return info cell, we have to go back to line 8 again. But the left-hand side is already resolved to a value of 5. We keep that resolved value because we are just taking care of the other side, which is invoke DS. That one is now replaced by a single question mark as a placeholder for the return value of DS. Then we can continue execution in the subroutine onto line 5. Line 5 is returning a value of 9. When we execute the return statement, we copy and paste the return info cell, change the question mark to the value that we are returning. In this case, it is 9. And that's all that we do. Once again, we do not do any printing. We do not say 5 plus 9 equals to 14. We simply change the question mark to the value that we are returning. And that's what line 5 is going to do. We move on to line 6. We take note of what return info is telling us, where do we have to go and what else do we have to do on that line. Copy and paste it into the line number column. And now we have no use of the return info cell because we just used it. So we deallocate that column. And then we continue execution on line 8 itself. So this is the third time we get to line 8. The first time we get to line 8, we invoke Johnny. The second time we get back onto line 8, we invoke DS. The third time we get to line 8, we do two things. One is the addition, 5 plus 9 equals to 14. And then the second thing we do is to print it out to the screen, which means at this point I need to allocate one column for comments just so that I know that this is printing something. I mean, if you're writing your notes, you don't really have to do that because it's not that important. Okay, so we print a value of 14 at this point to the screen. And this is my comments column. Yep.
I'm not really sure how the print statement works. The way you have it written, are you actually printing 5 and then adding that to 9? Or are you printing the sum of 5?
I'm printing the sum of the two numbers.
But do you technically need another set of brackets, or no?
In pseudocode, it's just printing the value after the evaluation. If I want to print 5 plus 9, as in just 5 and then the addition symbol and then 9, the whole thing will be in double quotes. Yep. So without the double quotes, we evaluate the expression and then find out what is the value of the expression and print that out.
So for the way the original statement read for line 8, it's not print bracket invoke Johnny plus invoke DS, but another bracket.
When you say bracket, are you referring to parentheses? If you add additional parentheses, it would not change the meaning of this statement.
Okay.
Yep. That's a convention that I borrow from a lot of the scripting languages. If anything that is not in double quotes will be evaluated first, and then you print the value of the expression and not the expression itself. Okay. That's a good question. All right, so after we execute line 8 finally, the third time, we can now move on because we are done with line 8. So now we move on to line 9, which is the end of the main subroutine. We make a note of we continue execution at post, and then we deallocate column C. and then we just continue execution at post, which means we are now at the finish line and we are all done. Okay, can everybody kind of relate this trace to the one before?
It's just nice to be able to see it all at once.
Right.
That was the hardest part of the other one. I just got lost.
That's one part of the difficult part. The other one also can be confusing because the invoke is on the same line as the return. But for that part, what you need to remember is what do you do when you execute the return statement. When you execute a return statement, it doesn't matter what is in the return info cell because your job is just to change the question mark. That's all that you do. Yep. Question? Nope. I'm waiting. You had a hand. Yep. No? Oh, okay. I misunderstood that.
There, so you have a question.
Oh, okay. Go ahead.
I think it's the previous algorithm would be a lot more fun if we actually realize what the f of n is and what the result is. It's basically telling you what the next sequence is, or
Right.
So
Yep.
the first n is we did 3, right? So the resulting number 2 is the third Fibonacci number in the
Yep.
sequence. So
Exactly.
if you try to extend it, it'll be more fun to.
Yeah, but beyond the third one, it's going to be
It's too long, yeah.
it's going to, because remember, it's going to go out and then come back in and go out again. So if I use, if I try to find the Fibonacci number of 4, it's going to be, a bit longer compared to the
Yeah.
one that I have now.
But it kind of puts it in perspective as far as, we understand
That is
what's
true.
what we're getting out of it, yeah.
Yep. Now is a good time to show you, after all of this, after making you guys trace everything, now we can take a look at App Inventor and say, can we write an app to do this? And not having to trace anything. We'll just let the program do it. Oh. That's my other password. All right. So we'll.
Is MIT no longer using Scratch, or are they just?
They're still using Scratch,
Okay.
but I just want to show you, how to write an app to do this, right?
Okay.
This is an app that I was just doing a little bit earlier, so we'll, just kind of get out of this one, and we'll implement this in App Inventor. There we go. So with an app like this, I need a text box, so I can input a number for n itself. I'm not going to spend too much time to make it look, nice. So I'm just going to say, this is my n, and I'll change the name of the text box accordingly. Oh. This screen is really kind of small for this purpose, but that's okay. So this is TBN, text box for n, and I'll just use a button to trigger the calculation. So the button, I'm going to rename it to BTN calculate. Calculate. There we go. And change the text accordingly. Calculate. There we go. And that's all I need for the user interface. I need a way to output the result too. And for that, I can use a notifier. Okay, and I'll show you guys what it does. It's basically the mechanism for the printing. All right, so now I have all the pieces I need with the user interface. It's time to actually specify the code. To specify the code, we switch from the designer to the blocks screen. The block screen is basically your code screen. Okay, in other words, a block is a statement. So when you assemble the blocks together, you're actually writing the pseudocode or the actual program to get this done. Everything is going to be triggered by the button. So I would say when button calculate is clicked, do the following. This is called event-driven programming, which means normally this program, when you load it, it doesn't do a single thing. Okay? Because until you press the button, there are no events to trigger any type of execution. The program just kind of sits there waiting for your input. Okay? But when you do click a button, whatever we specify inside this block will execute. We also need a subroutine to do the Fibonacci number calculation. So I'm going to, nope, not this one, because I need something that can return a value. So I'm going to use, to blah, blah, blah procedure and with a result. I'm going to name this, Fibonacci. It requires one operand, it requires one pass by value parameter. And this is how you add a parameter to a subroutine. You just drag and drop from here into the inputs. I can even change the name of the input to just n to be consistent with our pseudocode. So now we have defined sub fib. This is equivalent to our defined sub fib, and we can now specify the rest of the program. The rest of the program involves returning a value, but what value we are returning depends on the value of n, which means I need a multi-branch conditional statement that can return something. That turns out to be this block over here. Let's see, that can do it, but I'm just trying to figure out what is the best way to get this one done. We can do it this way. Yeah, let's go ahead and do it this way. Okay, so I have a conditional statement, but this is not a multi-branch conditional statement. It is just an if-then-else statement. So how can we do a multi-branch with only something like this? Well, we take care of the first thing first, which is when n equals to 0. We go to math here, and then we have a equality check here, and we just go ahead and say compare n to the value of 0. If that is true, what am I supposed to return when n equals to 0?
0.
Just return 0, right? So I just have to specify the value of 0 here. It's the else that is tricky, because I only get 2 branches with the if-then-else, so I can only handle 0 and one more case, which is non-zero, right? So how am I going to deal with the 2 cases of 1 and any number that is greater than 1?
Add another if statement.
Exactly, add another layer of if-then-else. So we go to control here, and then we just stack up another one. And this is nice. You can see the indentation stuff, is all automatically taken care of. I just drag and drop a block, snap it in, and I'm good to go. Okay, so now we check for n equals to 1. And since I'm really lazy, I'm just going to copy and paste that code here instead of dragging and dropping all over again. And now we are comparing n to 1. Well, if n equals to 1, I just need to return a value of 1. Okay, we can do that. So that's going to return a value of 1. If I get to this else here, that means n is neither 0 nor 1. That's the one time that I need to do the recursion, right? In the original code, in the definition of Fibonacci number, I have to return the f or Fibonacci of n minus 1 plus the Fibonacci of n minus 2. When you think in App Inventor, you have to think about what is the last operation first, and you specify the details. So the last operation we have to do is the addition. So we go to math, we drag and drop the addition block over here, and then we have to specify what do we put here. What should I put in the first slot? What is the Fibonacci number of 2? It is the Fibonacci number of 1 plus the Fibonacci number of 0. Okay, so that means recursion time, right? So recursion time means we go to procedure and look at all the subroutines that we have defined up to this point, which is just Fibonacci. So we're going to put it here, and we'll put it over here. The difference is, what do we pass as the parameter n here? The first one, well, it doesn't really matter whether you use n minus 1 for the first one and n minus 2 for the second one, or flip the order, because it is still going to be the same value. Okay, but it is n minus 1 and n minus 2, which means I have to specify the subtraction first, and then I will tell it what I'm supposed to subtract from what else. So we'll do the same thing here, and we'll drag n to go here. And the first one will do n minus 1. And then the second one will do n minus 2. So once again, we use parameter n, and then specify we are subtracting 2 from n in this case. Let me just zoom out a little bit so we can show the entire block. Okay, that's it. This is, App Inventor, expressing the logic of finding the Fibonacci number given n. Yep.
Would you need to restrict the inputs to all the numbers?
Yeah, but I'm not going to spend the time. I'm assuming the input is valid.
Okay.
But but you brought up a really good point, because input validation in real life programming can take up more than 50% of the code of any program. So 50% of the code is just to make sure that the input is valid, so you can actually process it. But in this case, I'm going to save some time and just assume the input is valid. Okay. All right. So now that we have the subroutine Fibonacci done correctly, well, it may be correct, may not be. We'll go ahead and say, but what do we do when the calculate button is clicked? Well, we want to do some printing, right? To do some printing here, we have to use what they call a notifier. A notifier has all of these ability to print something to the screen. Okay, sorry about that. Go back to here. We are going to pick the simplest one, which is this one here. It's just going to show a message box on screen, and we can control the message, the title, and also the button on the little message box. The message, well, let's go for the simplest one. In other words, I'm just going to print the value of the Fibonacci number instead of the Fibonacci number of blah is blah. Okay, so I'm not going to make it too complicated in this case. So that message is just the value of calling the Fibonacci number subroutine, and n is going to be the number that is specified in the text box. So I'm going to go to the text box here, which is TB, and we'll refer to the content of the text box, which is also called the text of the text box. And this is where scripting, or programming in App Inventor comes in handy, because if I kind of know that it's a number, I can just plug in the text where a number is expected. It can do the conversion automatically. As far as the title is concerned, we can just say the Fibonacci number is, and then the button text is just acknowledgement, right? I mean, yep, I got it. So we just say got it, and that's my entire program written in App Inventor. So next question is, how do I run it? I mean, here's a PC and here's an App Inventor. It's a program that is supposed to run in on an Android platform. Well, we can run it inside a virtual machine. I think we did this last time too. Yep. So we can do the same thing. So I'm going to start up the Android interface, and then we'll start up the virtual machine to run the application. So we'll go ahead and start up the virtual machine. And this is all free. MIT App Inventor is free. The Android software development kit is free as well. So if you guys can do this, just download the software, go to the website, and start, hacking away.
No pun intended.
Well, people think of hacking as always malicious, but that's actually not the case. Yeah. A hacker is basically anyone who use something not as intended. This might take a while, because this machine is slower than the other machine that in the other classroom. And I can try to find out why too. So let me see if I can find out why this machine is slower. Yep, that's why. The BIOS is locking out the virtual acceleration part of the processor, so that's why it is running slower. You can even find out what type of processor is on this machine and see whether it can actually do virtualization. It's an i3, oh okay, never mind. The i3 processor does not even have the, no it does. It has a VMX flag, which means it can accelerate virtualization, except it's turned off in the BIOS, so I'm not getting the speed up as a result. How many people? Go ahead.
To compile it, that program, or do you already have that?
Yeah, I have to do that too. Thanks for the reminder. But that won't take long. I mean, it's just downloading the APK file. That doesn't take too long. And the virtual machine is up. So you can see it is really kind of slow. Okay, let me save the file first. And then we go to the command line to run ADB. Double check the devices is there. And then we upload the program, and then we can run it. So ADB install -r temp. I'm just uploading the application right now and installing it on the virtual machine. All right. So now the virtual machine should have the program installed. And sure enough, we have fib. And we can now specify a value and then do the calculation. Which number do you want to try? Let's look up the sequence first, okay? Because we know the first few ones are pretty easy. So this is 0, 1, 2, 3, 4, 5, 6. Want to try 6?
Yeah.
Okay. So we'll specify 6. Calculate. The Fibonacci number is 8. Yeah, so it works. I mean, this is a really, really long detour, to test that particular algorithm, because not only am I not using a native programming interface, I have to run this inside a virtual machine, but I'm also illustrating how easy it is to write a simple app for the Android platform. I mean, if I go back to the program itself, that's the code. And I think most of you still remember the code that I had, for the timer, the game timer thing. Yeah, that's a lot more code compared to this one. And do you still remember why that one is kind of complicated? I mentioned that last time. Once again, yep.
Because it remembers where you were and it wasn't.
It has to do that, but a lot of the code also has to do with formatting time. So once again, it's user interaction again, because I have to parse the time format coming in, and I have to format the output too, so that my kids can actually tell how many minutes, how many hours, minutes, and seconds is left, instead of how many milliseconds is left, which will be easy, right? All right. So we are running out of time today. I'll see you guys next Tuesday, and don't forget that will be our exam 2 next Tuesday. Open book, open notes, just like the first exam. And if you come in late, you might want to find the row sheet and sign off on the row sheet too.